Hello viewers on YouTube. In this video tutorial, we are going to consider friction. So friction in terms of definition is a force that opposes motion. With the help of friction, an object that is moving can come to rest. Now this friction is split into two different forms, which include the static or starting frictional force, which is sometimes called the limiting frictional force, while the other one is the kinetic or sliding frictional force, which is also called the dynamic frictional force. But in this entire video, I will represent the first one as static and the other one as kinetic. There are still some other types of friction, but this has the most commonly pay attention to. So the static friction is denoted with F sub S. And in terms of magnitude, there is a formula that helps us to determine its value. So this formula is such that it's less or equals to the coefficient of static friction, which is known as mu sub S, multiplied by the normal reaction force, which is F sub n. Now, the kinetic friction, unlike this, is F sub k, and it's equals, this time around the inequality sign, by the product of its coefficient, that's mu sub k, multiplied by the normal reaction force. Now, before we proceed forward, the question you might ask is why is this having an inequality sign and this has an equal sign? Well, the reason is all because when an object is stationary, a certain force can just be applied to it. You can't just apply the force to it and expect it to begin to be in motion. Okay, so that is why it's always less than this. So when it's equal to it, then the object tends to begin to move. But when it's less than this, then you will eject back, okay, because the object will not move. You understand? Well, however, you still apply force to it. So that is why the static friction is always less than the product of its coefficient and that of the normal reaction force. Perfect. Now, from our common experience, we can clearly say that more forces is required to put an object that is stationary to begin to slide along the surface. You understand? Like I want an object to begin to move, more forces will be required to put it in that position than is required to keep an object in motion when it's beginning to move. You get what I'm saying makes sense. So if that is the case, we can clearly say that the kinetic friction, which is the friction due to motion, F sub k, is always less than the static friction, which is the friction we have to overcome in order for an object to begin in motion. Now, if that is the case, we can clearly say that mu k also is less than mu s. Why am I branching this? It's all because when we gain an example, you see what I'm saying makes sense. There are some problems whereby they won't specify what types of friction is given in terms of coefficients. You will be the one to identify it. If you are given two coefficients in a particular problem, just focus on the bigger one. The bigger one will be for the static, while the smaller one will be for the kinetic friction. Perfect. Now, if that is the case, we can proceed forward. So it is important to know the relationship between static friction and kinetic friction. You need to understand that the both friction can occur at the same time. Okay, one must be overcome before another one begins to show up. And once you keep that in mind, you should have no problem. Now, next thing is that you must know how to determine the normal force, which is called the reaction force, okay, of a particular problem, depending on the problem you're dealing with. But it's usually split into three different forms, and I'm going to describe that right away. So just listen to me and listen to me closely. So the first case is when an object is on a horizontal surface and sliding along the horizontal surface. So if an applied force is towards the left of the subject, okay, to determine the normal reaction force, this will be equal to the weight force of the object, okay, because in terms of definition, the normal reaction force is the force exerted back by a surface to an object in contact with it. So notice that the weight force of this object, if it is a block, for instance, block, would be what? Would be its mass, let's assume it is 5 kilogram, times the acceleration due to gravity. okay, the force of gravity. And usually the force of gravity or the acceleration of gravity is 10 meter per second squared. So G is usually 10 meter per second squared. Okay, perfect. So in this case, the weight force, W, it will be 5 times 10, which is 50 Newton. Perfect. Now, when an object is such that it's situated like this, then the normal reaction force, F sub n, will also be 50 Newton, because the surface will exert back same force as what is exerted on it. So if the weight force is exerted downward, okay, then the normal force, F sub n, will be exerted upward by the surface. Okay, this is the weight force. So this is the first case. So that you need to keep that in mind and keep track of that. Now the second case is when there's another force that presses down the object, okay, on the surface. What are we seeing next is consider the situation. So instead of for the applied force to be towards the left, this is applied Fa. Instead, it's applied on the object. So let's say this is the block, BLOCK. Okay, and it's still 5 kilogram. The mass is still 5 kilogram. Now there's now the applied force. Let's say the 10 Newton force, F sub A equals 10 Newton. Perfect. Now the weight force will still be mg, okay, because it will still be the force exerted on the surface. So weight force is still equals to mg, which is still 50 Newton. Okay, perfect. Now the weight force is exerted downward. Now we said the normal force is always perpendicular to the weight force. Okay, it will be opposite rather to the weight force. It will be directed upward. So this is the normal force, F sub n. Perfect. Now in this case, the normal force won't just support the weight force. It will also support this force that is mounted on the block. So in this case, the normal force will be more than the weight force. So the normal force is supporting two other different forces. In this case, the normal force will be equals to the weight force mg plus the applied force Fe, F sub A. And in this case, it will be the weight force is 50, the applied force is 10. So the normal force F sub n will be equal to 60 Newton. So this is what I'm saying makes sense. So you must know how to identify your applied force in order to succeed in determining whatever terms is associated with the frictional part. Perfect. Now the last case is when there's a tension force. So assuming we have a horizontal surface, then we have a block. Is this enough? Let's just work with that. We have a block this way. Now the force is such that it's resolved in two different ways, or it's along this way. So as we have a tension force. So this is a tension force that lifts the object a little bit above the surface, but it's still on the surface. Because when it's completely above the surface, then there will be no friction. But instead, the force of gravity. So assuming there's a particular angle theta, perfect. So we still have the block, BLOCK. Now you need to know that the weight force in this case will still be mg, because the acceleration of gravity will see what take effect. So weight force is still mg, and it's still 5 kilogram. If the mass is still 5 kilogram, then it means mg will be what, 50 Newton. Perfect. Now you can clearly see that we said the normal force will be opposite to the weight force, and it will be directed above, okay, by the surface onto the object. Now it won't just fully support the weight force the same amount, because it already has a supporter, okay, which has lifted the object a little bit above. So it won't fully support the entire weight force of the object, but instead some portion of it. Now to know the portion at which the normal force support, we can subtract the tension force, the one that help or that is giving the normal force a hand. We can subtract it from the weight force. Whatever is left will be the normal force. So it means the normal force in this case, F sub n, will be the weight force minus the tension force. Whatever we have left will be what the normal force is. So like I said earlier, you must know how to identify the normal force depending on the problem you're dealing with. And these are usually the three cases. So these are the most common one. But regardless, you have to be very careful. Perfect. Now the next thing we have to consider is that you have to know the relationship between the static friction, kinetic, and the net force. Okay, let me just get to this. If you haven't written it down, you can pause the video and have it copied in the notes. Perfect. Now, I will like to disclose that with the help of a theory. Let's consider a static friction, F sub S, then a kinetic friction, F sub K, then the applied force, that will be here, F sub A, and the net force, that will be here, which is usually the summation of F. Okay, oops, let's do back, let's do that again. Perfect. Here. Now, let's say the static friction of a particular object is 20 Newton. F sub S is equal to 20 Newton. Perfect. Now, assuming the object is on a horizontal surface, assuming this is the object and is on a horizontal surface. Now, we want to put this object in motion. Then an applied force of 10 Newton is applied to this object. 10 Newton, sorry. Okay, an applied force of 10 Newton is applied to this object. The question is, what will be the static friction, the kinetic friction, and the net force? And also, will the object will it move? Will we be able to put it in motion with the 10 Newton force we want to apply to it? Now, what you need to understand is that as long as the applied force is not up to the threshold or the minimum static frictional force, then the object will not move. That's one thing you need to keep in account. Secondly, is that as long as the applied force is not up to the static friction, the frictional and static friction will always match the applied force. Because you can think of it this way in reality. You can, assuming you are trying to push an object and you apply the force to it, and you realizing that instead the object is the one pushing you. And initially the object is stationary. You can see that's absolutely impossible. A stationary object, when applied force is applied to it, then you can't expect the force to not be the one moving. It will instead jack. Perfect. So therefore, as long as the applied force is not up to the static friction force, then the static friction force will match the applied force. So in this case, the static friction force will be 10 Newton. Since they oppose themselves, therefore the net force will be 0 because they will subtract themselves. If this is directed this way, this will go this way. If this goes this way, this will come this way. They oppose themselves and they are going to get rid of themselves. Perfect. Now in this case, since we said when static friction occurs, kinetic will not occur. Kinetic will be 0. When kinetic occurs, static will not occur. Static will be 0. Perfect. Now let's say for instance we apply 15 Newton to heat. Will it move? Never. What will be static? Static will still be 15. But kinetic will still be 0 and net force will still be 0. Now let's now take for instance we now apply the force that is more than or equal, let's say equal to this 20 Newton. Okay, now what will be the static friction in this case? Static friction will still be what? Will still be 20 because it will invert symptom, and therefore kinetic will still be 0 and this will still be 0. But when we now apply the force that is more than the static friction, that's 21 Newton. In this case, the object is going to move, and there will be no more static friction, but instead a kinetic friction. So static friction will now be 0. Now, like we said earlier, kinetic friction needs to be less than the static friction. So which means the kinetic friction we'll be having in this case will still not be up to 20. So let's say for instance 19 Newton. And as long as kinetic friction is present, there will be net force. And in this case, if we subtract this, we'll be left with 2 Newton. So the net force will be 2 Newton. So that is what is connecting them. Some question will just ask you, okay, what is the kinetic friction, or what is the threshold for applied force, and so on, and you will be asked, will the object move? Will the object be in motion, and so on. So for you to know if it's going to be in motion, the applied force must be more than the static frictional force. Sometimes there's some problem that we say that when they are equal or some textbooks, the object will be about to begin to go into motion. But the reality is the applied force must be at least some units away from the static frictional force. Are we together? That's how that work. Once applied force is more than the static frictional force, then the object will begin to move. Otherwise, it will still remain unchanged or stationary. And I hope with this few points, you can now understand the types of frictions and how to deal with problems involving it. Now, in this video, we are going to consider how to make use of all these formulas effectively in dealing with physics problems involving frictional force. Thank you. If you have any questions, feel free to drop it in the comment section below. See you in the next video. Bye for now.